Hello everyone. So today I'm going to talk about supervised machine learning and also show you some code in scikit-learn libraries using Python. So first and foremost, machine learning categories have three parts: supervised learning, unsupervised learning, and reinforcement learning. So today we're going to focus on supervised learning, which consists of regression and classification. So the first algorithm in supervised learning is linear regression. This is actually a form of compression because we're using a linear model to represent the whole data set. So linear regression is using a linear relationship between the response variable y and also the predictor variable x. So this is the code example of a linear regression model using the statistics package. In the summary table, you can see there's a lot of useful statistics, such as adjusted R-squared, which tell you the goodness of fit of the model. And there's several t-tests and p-value results of the t-test telling you if specific predictors are significant in predicting the variable y. And also there's other statistics like JB test, omnibus test, which can tell you if the data set satisfies a linear model assumptions. And on the right-hand side, you can see this is how you call the linear regression model in scikit-learn package. The next one is classification algorithm. It has a lot of different classification algorithm. The first thing we're going to talk about is logistic regression. This is actually very similar with a linear regression, except the fact that now the response variable y is no longer numeric, but rather is binary variable, which follow a Bernoulli distribution. And what we can do is we'll apply a logic function on the response variable to make it continuous. And the right-hand side, we still keep it as the same. Okay. And the right-hand side is how you call the logistic regression in scikit-learn, which is pretty straightforward too. And next is the decision trees. So decision trees is actually using the tree structures. It's based on information loss and gain. So at each level of the tree, we're trying to think what is the one rule that separates and distinguish the data into two groups. But actually decision trees can be very complex, as the second picture shown below. It can be very easy to overfit the data because decision trees can ask a lot of very detailed questions and capture unimportant and unnecessary details. So one solution to the overfitting is using random forest. So instead of a single complex tree, as we saw in the previous slide, a random forest will sample the data and build several smaller, simpler trees. So each tree is smaller because it's built from a subset of the data, not the whole data set. So each tree, collectively, they can form a strong classifier too. And this is the code example of random forest, which we can also discuss later and play around later. To sum up, today we talk about two major algorithm for supervised machine learning: linear regression and classification. So in classification, there's obviously other algorithm other than logistic regression and decision trees, which we'll talk about deeply in next module. And thanks for attention.